Just to quickly introduce myself, in Germany I'm known as Piotr ohne Vokale, and the talk today is beyond good old text search. So everything what Hamid said still works, continues to work, it's being improved, and so on. I work for Elastic as senior developer advocate. I come from Java background, also like testing, but this is what Elastic is doing, right? So there's search, observability, security, also like some help with the generative AI. But today I'm focusing on this search part, right? So as you may know, Elasticsearch is the thing that started it all, and it's for search. If you want to run it locally, I want to show you. You can basically run this script, and it will start if you want to like play with some of these features on your computer, because you might have like proprietary data or something like this. All you need is Docker Compose, and then you go and it will run the two containers on your machine, and they come from Docker Elasticsearch. So if you're using if you run Elasticsearch or Kibana or whatever that's coming from Elastic, please use Docker Elasticsearch. Or if you don't want to get your heads dirty, you can always go to Cloud Elasticsearch and go for the free trial. There are two options. You can go for hosted option or serverless option, whatever works for you. And if you go for the serverless option, as you can see, you can choose from the regular Elasticsearch, Elasticsearch for observability, and Elastic for security. And if I'm going just like now for Elasticsearch, this is the first one, I then can choose, is it for general purpose or optimized for vectors? And that's already a hint, right? That you might get something perhaps nicer. And if you care about low peak, of course, you go for Frankfurt. Yes. And this comes from my friend Siva, right? We used to work together. These days, people are becoming experts in AI. The problem with AI and with many other systems is this. If you put garbage in, you will get garbage out, right? So the key important is, when they talk about this context is, whether it's RAG or MCP or whatever, you need to make sure that what it gets is not rubbish, right? Or as far as rubbish as possible, that it's accurate, small, and so on. That's why you need to search through the stuff you have, right? And therefore, apart from all this stuff that Hamid already covered, like BM25, IDF, and all the fancy acronyms, there's more these days. Because, Elasticsearch is now also for vector search. For example, when people say vector search, then you usually mean something like dense vector. But there's also sparse vector, and there's a field/feature in Elasticsearch called semantic text, right? How does it work? When you have this good old SQL query, for example, someone types in your search bar milk chocolate, right? You tokenize it, separate by white characters, and there you go, you search something like this. The question is, did they really type milk chocolate or chocolate milk? Because depending on what they type, the user, right, you may want to offer them something else from your inventory, because maybe they are into sweets, or maybe they are more into beverages. You don't know. So if you just go for milk and chocolate, you might end up showing them irrelevant stuff. That's why semantics, the meaning matters, okay? So the first thing is, and what you can go for is a dense vector. So basically, it's a sequence, or you can think an array of numbers. Usually these are floating numbers, right? So like in Java, this would be, for example, float. You can say that every number is important and has some meaning because as many numbers you have, there are as many dimensions basically, and they can represent also anything. This could be text, image, song, models which can, for example, understand two, like text and an image, right? And give you an embedding based on one or the other. It works, you can spin the model wherever you want. It could be on your premises, on your hardware, in the cloud. You can hit a SaaS product from somebody else, or you can run these models if they met some criteria as part of your Elasticsearch cluster, right? Here, of course, is the documentation, because the documentation is very important. And if you fancy more into this, there are these, I would say, buzzwords like KNN, HNSW, and brute force, all right? Depending what you need, what you're after. When people ask me, okay, so what it actually is, do you recognize this scene? What film is it from? Matrix, the movie. So this is what we saw, the lady in a red dress walking next to the fountain, everybody else dressed in a black suit and everything, right? What Trinity and Morpheus saw was this. So we can think this is vector representation of this stuff. Okay, this is the very non-scientific explanation, but to give you a glimpse what it can be seen as. Then if we run something like this, and as you can see here, I'm hitting Olama, right? And I'm asking like, hey, give me an embedding, because this thing, this vector representation is called embedding, like, okay, to be super accurate. And I'm choosing like a model that works for me, right? Has proper number of dimensions, understands my domain and whatever. And I'm sending this, this prompt, right? And then I get the embedding. So these are the numbers, right? Basically floating numbers. And when I change it slightly and I say in an orange dress, as you can see, the numbers change in all positions. Let me show you that to you. So they don't differ vastly, but they already change. That's why I said every number has like some meaning. What I'm trying to say, in other words, is this: if the sentence or the prompt like changes at the very end, it's not that the very few numbers at the end will change. Okay, it grasps the meaning of the whole prompt and will give you a vector in this multi-dimensional space that sits exactly here or there if we narrow this to 3 dimensions, right? And that's important when we want to calculate like how near or how close this stuff is, right? When we compare various embeddings. And you can also like deploy these models into Elasticsearch, right? So we can hit post request, right? And this is just to give you like when I want to do the same thing like I just did with Olama, right? And I have this model deployed, then I will get this as a predicted value / embedding. So this is how basically the stuff can be also calculated inside Elasticsearch cluster. There are issues with that. Normally it needs, or by default, or if you don't tune it, it needs a lot of memory, because suddenly for this text you get, for example, 500 numbers, okay, floating point numbers. Indexing is slower and merging can be slower. And of course, there are continuous improvements in Lucene Elasticsearch. That's why it's important that you stay on the latest version, I would say, because you might get these upgrades for free. And there are, of course, best practices. It's always working good if you don't search during indexing, just because of the CQRS reasons, for example, explain. It helps if you exclude vectors from source, and sometimes if you reduce dimensionality or use simpler types rather than float. And this can be seen like these two in here in this picture. I mean, if our model is giving us this vector, right? Maybe what we can do is like we can go fewer dimensions, or we can have less precision in every dimension. And even despite this reduction, we can still get results which are relevant enough. So we pay way less or significantly less. The stuff works faster, and our results are still good enough. All right. And if you fancy to read about this, there's the documentation about this dense vector type, right? What changed over the last few versions is this, right? So you can also enable by default. Sorry, you can enable this. Not by default, you can enable the so-called quantization. So the stuff can be done for you. What it practically does. To search this stuff properly, right, it's not a brute force. I mean, unless you want to. So it's using this graph, this memory structure called hierarchical navigable small worlds. It basically is like a layered graph, right? And then every node is this vector, right? And to reduce the size of it in RAM, right, what we can do is like, instead of keeping the floats, we can keep numbers with less precision. Even going like we can go int 8, int 4, or even BBQ. And that means that for every dimension, we'll keep just 1 bit, 0 or 1. And you may say, no chance it's gonna work. Well, what it does is this. This reduced the memory consumption by 32 times just for this structure, right? And how we handle this is just we go for oversampling. So instead, for example, you're looking for 10 hits, right? So you select, for example, if we go for like a few more, let's say, then you get like a 30, and then you do sort of like brute force through this 30. This is how it works. Then you sacrifice perhaps a little bit the accuracy by, I don't want to like toss the numbers, but let's say like 3% or something, and you reduce the memory consumption, the RAM consumption for this by, as you can see, 30 times, right? So there are ways to handle this. And there are other ways to go faster, right? I will toss you a few links, right? So these are, for example, why you shouldn't stay like old 8 or 7, right? Because things got improved. 9.1 came with this Acron 1, which is great if you have vector search combined with filters. There's this early termination for this HNSW. And for example, if you still don't have enough RAM, you can go and for example, enable direct IO. This is Java thingy. TLDR, stay of the latest version. This whole vector thingy is really evolving quite fast, right? So these are, for example, based on like this on scientific paper. So something was released and implemented a few months later. So if you have a version that predates the paper, I mean, good luck. It will still work in like a basic version, but it will be like slower, for example, or less accurate or something. Then there is the other kind of vector, which is the sparse vector. It's basically, you can think like a dictionary or a map, and it's representing text. And again, it can be, you can run the models inside your Elasticsearch cluster or like somewhere else. And the dimensions are mostly like 0 or very close to 0. I mean, the values in the dimensions, and therefore we care about the few ones which are significant. Like imagine you have like a gazillion of dimensions and only a few are like peak, and we keep these peaks, right? There's documentation, and the buzzword is ELSA, because ELSA is the model which was trained by Elastic to produce these sparse vectors for English. It's not a wall of text, but 3 lines of text, okay? What's important is this. It's not a dense vector encoder, it's not a synonym list, right? Or it's not a replacement for BM25. It's something else. And what it is, for example, is, apart from the condition, I hope to show you this. So we again run the same prompt through ELSA, right? And this is how you can see it looks like. So like I told you, a map, a dictionary, and then you see that there are these hits, like you get like Hamlet or she or picture or illusion. The simplified version is this. It was trained on a corpus, right? Like a big number of text, like a lot of text. And basically, if in a piece of text there was a fountain, or say, so let's say a scene, the chances were, for example, it will also be Hamlet or drama. That's why it's like, let's say these words are likely to happen, right? So this you can also use for search. It can be useful, for example, if people are not sure what they want to say. They say, for example, drama, but or what they actually need, like it's like a theater or scene or something like this. Oversimplified example. And there is a third type of field, which is called semantic text. And basically it's this. If you didn't do anything in like related to vectors, like dense vectors or sparse vectors, maybe this is what the way for you to start, to just go semantic underscore text as the type of your field, right? It works only for representing text because it also has to support sparse and vectors, right? Right now it works only with models running in Elasticsearch cluster, so the models have to be deployed. You can't call a third-party thingy. It gives you automated chunking, right? So cutting the text into pieces, because if you have like, let's say your text is like 4 pages long, you can't just have 500 numbers to represent this whole text, right? So you need to cut it into small pieces. You need to chunk it. So this is automated, and under the hood, or when you define it, you can say it's going to be dense vector or sparse vector. That's why it will just do like the whole magic for you. And how do you deploy this model? So basically, like a place where these models live is Hugging Face. So you go to Hugging Face, you find a model that can run, and you can import it using a thing called eland. I usually go the Docker way. Basically, there's like a Docker importer, right? And it stopped working. I don't know why. And then you have these models imported, and you can basically use them inside your Elasticsearch cluster. There are many of these models, so they can not just create these embeddings, but, for example, classify stuff, right? Then, I mean, if you talk, for example, about these dense vectors, especially, we can go 2 ways, because these vectors need to happen in the document somehow, right? Because you need to search using these vectors, right? So either you generate them on this side and you just include them here on your, I don't know, like rerun this stuff, like reindex with like some others like embeddings, or if you have them deployed, you can have like inference pipeline basically enrich, just like we have pipeline for regular ingestion, right? Nothing fancy here, except it's hitting machine learning stuff. And yes, I wanted to show you a few of these. What I'm using here is like my serverless deployment, right? And let me just, for example, introduce myself. I hope it's all properly pre-warmed. So see, this is the prompt. Hello, my name is Piotr and I live in Wrocław, Poland, right? Auf Deutsch Breslau. And it tells me that I'm most probably a person, and Wrocław and Poland are locations. For example, you run your logs through and you want to get rid of personal information. You need to identify it, get rid of it, right? Or you need to identify which shop, for example, got negative comments, or restaurant in your chain of restaurants, something like this. If you go for this, we had to wait for half an hour for our French fries, right? You can say that this is most probably a negative sentiment, right? And then you can even try to identify the emotion. It's anger. These people are angry, right? Most probably because they didn't get the French fries, right? And then, of course, you can generate the dense embedding. if you need to, right? Or you can generate the sparse embedding using ELSA, right? So this is how it, sorry, it's still the dense, this is ELSA, yes. So wait, fries, see, I didn't say potatoes, right? But there are potatoes here and delay, because when it was trained, potatoes happen to be relatively often in the same text as fries. No surprise, given how, I mean, French fries usually are made out of potatoes, right? And so on. And then I'll show you, I have a quick index here, or small index here, and I generated embeddings for the title. So normally title is type text, right? This is like, because I've run a web crawler, and I created title, dense, which is dense vector field. This is semantic text. This is also semantic text, but under the hood, this is dense, this is sparse, and I have this sparse vector, right? And they are like, what you really need, right? How it works is this. I mean, this is like how you run it, like in a pipeline, ingest, enrich, blah, 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 and so on. Like, yeah, you can go, for example, for this BBQ, right, to save this memory. This is the beauty if you're using a semantic text, right? This is your whole query, because the field has been predefined that it's, for example, sparse vector using ELSA model, right? And this is easier, for example, than sending the whole vector, which normally you would need to calculate somewhere on the side, right? So this is the benefit you have. Instead, like if you have dense vector, you need to usually like get it somewhere. If you have semantic text, I mean, it's not like a hard-coded rule, right? This could also be like calculated because you can have this query builder, right? But then this is free version, and semantic text, I'm afraid, is also like as a field type, is free version. But to be able to deploy these models, you need to go for some paid license, right? I mean, it is what it is. Running this stuff in cloud or something, this like someone eventually has to pay for this. So that's that, and maybe I can show you these trained models. I have some trained models here, the ones which are important with ELSA, right? With Eland. Let me just make it, maybe like shrink it a little. I hope you can still see it. Yes, and this was this. Hamed said we need to identify language using an LLM, right? So this is it, right? Embedded. So let me type zarzuć gęślą, and I guess you know which language that is. Exactly. Let's check if the LLM is equally smart as you are, right? It says it's 8% Polish, and I guess it. Why does it think it's almost 20% from Azerbaijan? I have no clue. Don't ask me. And this is like, the lazy folks jumped over brown dog or something like this. Basically, it doesn't mean anything in Polish. It's just to have everyday critics. So if you're into fonts and something, this is what you use in Polish. Right. And so as you can see, this is like deployed to my cluster, and I should have these other ones. This is how you basically use them. There's also the other thing Hamid mentioned, that there's hybrid search. For example, you've been using Elasticsearch version 7, BM25, stemming, tokenization, filtering, removing tags, purifying everything. You have that working. It's beautiful, right? And you don't want to jump right now into these vectors. It shouldn't be one or the other. And this is the idea behind hybrid search, that you can combine the results from both worlds, right? So let's say what we are selling is we have a fashion store, right? And as you can see in this query, we're searching through our catalog, or you don't see it on the top. Trust me, it's product catalog /_search. So this is a proper query here, as you can see. And you've imported some test data to your machine or to staging, and you've been running random queries, by a rule of thumb, like Pi mal Daumen. You came to this idea that to get both of these sort of aligned, you need to boost this by 0.9 and this one by 0.1, right? So we're just looking in the department for women for summer clothes, right? And this is the prompt, and this is the query, and this is the query translated to vector embedding. Important thing, if you use a model to create the embeddings that are stored in Elasticsearch, you need to use exactly the same model to translate the query into embedding. Else, you'll be comparing peaches to potatoes, right? Just because it has, for example, 128 numbers, it doesn't mean it will work. You will get like rubbish. So some people apparently forget about this. And this is the query, right? It works very nice if you search for summer clothes, right? And now you wanted to clone this to run another shop. Now you're into automotive, right? Of course, we're in Germany, and someone looks for Heckscheibenwaschanlage. If you don't speak German, that should be a rear window sprinkler device, right? Good luck trying to find it with the same boost, and good luck applying the same stuff and using the same stuff for German or some other languages, right? And I guess guys from this office know it better than I do, right? Yes, so what you can do instead, you can go into this approach with Formula One races or ski jumping, right? You won one race, you were second in another race, let's say in Monaco, and you were third somewhere in I don't know, Saudi Arabia or whatever they run these races, right? And then all the results are combined because you had this position in this race, this position in that race, and then at the end of the year it's combined, and we know which driver was the most successful one through the whole season, and who's the second and who's the third, right? So we combine the results. I mean, that's the idea behind hybrid search, at least when we go to RRF. That stands for reciprocal rank fusion, and trust me, this is the most difficult part about this algorithm because it's relatively simple, just 2 pages to implement this. What it basically does is, like I told you, it has like a few magic numbers which you can tune, but we forget about these boosts, right? We don't have like these handcrafted boosts, and instead of this, we just wrap them in retriever, RRF, we list the retrievers, and this is like one race in the Monaco, this is another race in the US, it gets like a properly, unlike here, we don't compare like peaches to potatoes, we just normalize everything, standardize, and so on. That's why this hybrid search is nice, for example, if you have dense vector search and good old text search, right? And of course, you can combine it with, let's say, sparse vector as well. You're not limited to 2. You can toss as many as you need because of your use case, right? And speaking of this, so that's the if you need to know more about this, I of course encourage you to. Let's wrap it up. We're using ESQL. If I'm not mistaken, it looks for the top 5 most hit resources apart from like HTML, right? And we sort of like got used to it. Okay, so ESQL looks like this. You can use it, for example, in your Java query, and it integrates nicely as result set, which is JDBC, very standard Java thinking. So this could be like a regular language you use to hit Elasticsearch as your search backend. And you can go for more sophisticated versions with parameters and so on. Right, it works very nicely with records. Or, for example, if you just use it in Kibana, in DevTools, or you sell like SQL query, it will also give you results, right? And as you can see, by default, it's just JSON with some metadata and some values. This is very nice if we talk about GenAI, because then it means that the LLMs can easier run these queries, right? Because they understand, or it's easy for them to understand what they actually produce. If you fancy, you can get this, you can change the format to text. That will give you text like this. It's who runs Excel? Every company does, okay? So we can go for CSV and easily import into Excel if you need that, right? You can go for YAML. Do you know what YAML stands for? Yelling at my laptop, okay? That's why this format was invented, okay? So you can get, as you can see, way more stuff, right? So TLDR, with this language, where you can run these sort queries, you can select fields, drop fields from the calculation. You can go for dissect or eval to calculate stuff. You can have these starts, right? You can enrich or lookup using lookups. As you can see, lookup join now. If you're running one of the latest versions of Elasticsearch, you can go for lookup join. You can have sorts. So this is something like in between piping, like in Bash, and SQL, right? And it's not ESQL, it's ESQL with the pipe in the middle. And now you know why the pipe is there, right? You can easily change the lines, right? You can copy and paste from one query to another. This works not just for backends, but for example, for observability folks, right? When they create their dashboards and alerting and so on. So I love it very much because it's just finally one language that I can use everywhere, right? I can handcraft the query in Kibana as backend developer and then copy and paste to my Java code or whatever other language I use, right? It's not just new language and new endpoint. It's also there's also a new engine that has different performance characteristics. And why is that? Because as you can see, it's running like when we release a Docker image, it's running on the latest Java version. You know, Elasticsearch is written in Java, right? And then it's using one of these incubator features of Java, which is vector. Basically, this means that it will try to squeeze as much as possible from your CPUs. Java itself recognizes what CPU it is. And if you write your program correctly or using this new API, it will basically do the arithmetics as fast as it can. Sometimes it can be like, let's say, 4 times faster. And sometimes it will be like 90% of the original. Sometimes it gets slower, right? So that's why I say it's different performance characteristics, but most of the time it's faster. If you need to know more about this new language, which is available since 8.14, the first version, and then with every new version, there are new features tossed, right? And I think it was like discussed deeper during one of the few last meetups here in Berlin. If you want to try this stuff out, this is how we can try with Elasticsearch. If you don't happen to have it on your hands, right, just go for this to run locally. If you have Docker or for this trial, which is like free as in you don't have to type the details of your credit card and oops, I've forgotten and now I'm charged, right? Here's the documentation and here's the search labs, right? So this is like a series of blogs that we publish about the Elasticsearch, the whole Elastic stack. If you have some questions about some stuff, and that is like the free and open source version, we are more than welcome to go to discuss Elasticsearch and ask these questions, right? And we'll try to answer. If you're more like Slack person, you can go to our Slack workspace, right? Or if you want to visit a meetup like this one, but we also run in other cities, please do, right? There's a whole list of them. There are quite many, I would say. And all these links are available if you scan or follow this link, right? So this Discuss, Slack, and the meetups. I don't know, maybe you have friends in München or, I don't know, in Amsterdam or London, like your teammates or somebody else. Guten Appetit wünsche ich.